Hello, Math 30. Um, Lesson 3 in solving trig equations is about, the title says solving equations involving multiple angles, but really what we want the outcome to be is about um, us solving equations where there is a b value, or as we talked about in our trig transformation, there is a horizontal stretch. So this is really no different, but you'll notice there's a 3 and there's a 2. How does that change it from an original equation of maybe sine x equals root 3 over 2 or cosine just plain x? We've already solved those questions. So how does it change when you have that coefficient? If secant had just been equal to 2 or sine x equal to root 3 over 2, how would that change that question? So what we want you to do, what I want you to do is to go through, use your graphing calculator and compare what the answers look like visually by using your calculator from 0 to 360. So keep your window at 0 to 360. My suggestion would be that instead of having a scale of 30 degrees, have your X window from 0 to 360, but put it in 15 degrees. And have your Y scale, obviously you can have your Y scale here from -2 to 2 and go by ones. That part doesn't really matter a whole lot, but it would be best if you have a 15-degree scale, and you'll see why. Okay, so go and graph it and see what you come up with, all right? And then answer the questions that are there. So if you graph y equals cosine in green, and you graph y equals minus root 3 over 2, and you look at the intersections, you can see that the first graph has solutions of 150 and 210. And we could have done that algebraically as well. What difference does it make if you throw a 2 into the cosine? Well, we know that from our graphing that that's a horizontal stretch by a factor of a half. And so as you can see, our wave occurs twice as fast, and we get answers of 75, 255, 75, 105, 255, and 285. And now we ponder, what does that say about the number of solutions? Well, clearly we have twice as many. But what about their value? Well, our primary ones from our base, and we always go to that one first rotation. So our primary numbers, well, we can see that the first two answers are 1/2 of the original. But the other thing we notice too is when you compare 105 to 200, when you compare 75 to 255 to get your next set, well, that's only 180 degrees, right? I'll use a different color there. So when you compare 75 to 255, that's only 180 degrees. And when you compare 185 to 285, that's 180 degrees more. So that's the other thing you notice. The first two answers are half the original, and the next answers are found by adding 180. And I wonder why that is. Well, might have to do with the period of the new graph, that because we've horizontally stretched by a half, that new graph doesn't take 2 pi to finish. So adding 360 may not be necessary. The general solution for our first answer is, and you can write those in and fill in this next blank, right? So as you can see, as we would have done in lessons 1 and 2, the general solution for root 3 over 2, 150 plus 360, n is the one set of angles, and the other set is 210 plus 360. Each of those sets is separated by 360 degrees, because to get to the next terminal arm, in the same position is 360 degrees. In the other situation with cos 2x, the wave is happening faster, and it takes 180 degrees to get back to the same spot. So there are two answers that are separated by 180 because it has a period of 180. A horizontal stretch, as you can see, by 1/2. The general solution to this one is two sets. Set number 1 is 75 plus 180 n is now integers, and 105 plus 180 n, where n is now integers. Right? So we've hopefully explored and learned a little bit about what happens when you make it twice as fast. That, as you can see in the picture, horizontally stretching it can affect it. You can get twice as many answers and they're half as big when you have a b value of 2. Clearly that changes depending on the b value you have, right? But it does have an impact on the solutions. We need to find an algebraic approach for this happening. We're going to leave tangent now. Let's just go straight to the algebraic approach for happening, because clearly we could do it graphically with tangent as well, but let's just develop the approach. So consider the equation sine 3x over. Sine 3x is equal to root 3 over 2. In a general sense, you're going to just calculate the answer like we talked about and just pretend that this 3x is just not there, that there hasn't been any horizontal stretch at all. You're going to ignore the 3 for the time being. This is defined from 0 to 3, from x is defined from 0 to 2 pi, but you do have to redefine the domain, because now if you have a 3x, clearly an equivalent statement would be 3x is between 3 times 0 is 0 and 3 times 2 pi is 6 pi. So you have to redefine your domain. If x can be between 0 and 2 pi, clearly 3x can be between 0 and 6 pi. All right, and now we go back to the same procedure. Sine 3x is positive, so it needs to be in quadrants 1 and quadrants 2. The reference angle is clearly going to be pi over 4. Therefore, 3x is equal to pi over 4, or 3 pi over 4. Or on the next rotation, it's 2 pi plus pi over 4, and 2 pi plus 3 pi over 4. Or on the next rotation, so 2 rotations, it would be 4 pi plus pi over 4 and 4 pi plus 3 pi over 4. And as long as you're okay with equivalent fractions, you can now write all the answers from 0 to 6 pi. So the answers there to find the next rotation, the sets of angles, right? Oopsie, I think I missed one. Oh, that belongs here. So to find those 3 sets of angles for each rotation from 0 to 6 pi, we just keep adding 8 pi over 4. So therefore x is equal to, when you divide by 3, our final answer is x is equal to pi over 12, 3 pi over 12, 9 pi over 12, 11 pi over 12, 17 pi over 12, and 19 pi over 12. And you'll notice that now in your final answers, the value of x is not any more than 2 pi. The general solution, though, to this situation would be found by using these 2 sets of angles. So now that you want a general solution, and with the general solution, keep in mind that because of that 3, the period of this graph is equal to 2 pi times 1/3. So the period of this graph is equal to 2 pi over 3. So all I simply have to do for the general solution is to take my first 2 answers that I have and write 2 statements. Statement number 1 says pi over 12 plus 2 pi over 3 n, where n is an element of integers, and the other statement is 3 pi over 12 plus 2 pi over 3n, where n is an element of integers. And those are my 2 key answers to finding, or my 2 key answers to writing all the general solutions. You can verify by using that. So the general solution consists of 2 sets of answers that are differed by 2 pi radians because it has a period of 2 pi over 3. All right. When we look at the procedure for it, so what that procedure is really talking about is what you just did on the previous page right here. So when you consider what we did here in the procedure we used, it's just trying to give you a recipe for repeating that. So to find the domain for the multiple angle, what it's saying is that if, for example, if the domain of x is greater than or equal to 0 but less than or equal to pi like it was in the last one, and we have a b value, right? So now we're talking about y equals, let's say, sine of 5x. Well, the multiple angle is 5. That means that my restriction for the domain would be 5x is greater than or equal to 0, but less than or equal to 10 pi. And so you're going to have to go around the unit circle 5 times because you've got a 10 pi restriction. So now we solve for the multiple angle between 0 and 2 pi. So that's saying, well, what are the two principal angles that satisfy this condition using the cast rule and reference angle? So we're going to find those 5x answers. So we find the reference angle, find that, and we find those first two answers from 0 to 2 pi or 0 to 360. Now that we have them, you've got to go, and in step 3, you're saying, well, now you know the first two answers for that, but now you have to go and using the period, right? Sorry, I misspoke. So in step 2, you'll solve for the actual multiplying. You will find those first two angles for 5x between 0 and 360 or 0 2 pi, and then you'll actually divide by 5, and you'll actually get your first two answers for just plain old x. Okay? Okay. Well, let's just finish off this procedure. So 5x, we find those first two answers like we did in the last one. Then we'll go and use the period for the graph, and we will find all the answers. So we'll find 5x, and you're going to have to find that first set, a second set, a third set, a fourth set, and you'll even find a fifth set because you're going to have to go through the whole period of 10 pi. We'll add that period, find all those multiple angles until you cover the domain of step 1. And the only thing that's missing in the fourth step is you still have to divide all your 5x answers and end up with x equals those answers there, right? So let's do the steps with example 2 and see what you come up with. All right, so first step, x is normally 0 to 2 pi. That means 2x is 0 to 4 pi. The next thing is that the reference angle for 5x is pi over 6. So that means that on the first rotation of 2 pi, that my angles for 5x are 7 pi over 6 and also 11 pi over 6. On to step 3. Oh, Mr. K, you're being silly. It's not 5x, it's 2x and 2x. We just were talking about 5x up top there. So now in part 3, all the possible answers for 2x, we have to find the other solutions. The first two solutions were 7 pi over 6 and 11 pi over 6. But we know that to get to the next solution, we have to add 2 pi. So I add 2 pi to get to the next one, and I also add 2 pi to 11 pi over 6 to get to the next set of answers. And so the next set of answers are going to be, in this case, so there's my other set of answers there, 19 pi over 6 and 23 pi over 6. I don't need to go farther because that's the cutoff of 4 pi. I don't need to go past that. Those are all my answers for 2x, but my final answer in step 4 is that my actual answers for x need to be divided by 2. So 7 pi over 12 and 11 pi over 12 and 19 pi over 12, and lastly 23 pi over 12, and those answers fit within our 0 to 2 pi for x. The general solution, though, would be x equals 7 pi over 12 plus pi n, where n is an element of integers, and also 19 pi over 12 plus pi n, where n is an element of integers. I believe I said 19 pi over 12, but it's 11 pi over 12 plus pi n. The general solutions of answers which differ by pi radians because the graph of y equals sine 2x has a period of pi radians, and we can verify it graphically. We want to make sure when we look at the last example that we have here, we are going to, a question like this we did in the last unit, and we're going to stick with the calculator to do that question. Enjoy the assignment.